Hello everyone, welcome to our sessions. In this series of videos, we are going to cover 9 chapters of Pure Mathematics 1. Chapter 5 is straight line graphs. Topic 5.1 is y is equal to mx plus c, which is the line equation. In this video, we are going to do explanation of each topic. We'll do some exercise questions, do some past paper questions, and we'll give you some exam success tips so you can excel in your Edexcel. So let's start our journey. Topic 5.1 is y is equal to mx plus c. This is a general equation for a straight line. To find the gradient of a straight line, we need a two coordinate x1, y1 and x2, y2. And this is the formula m is equal to y2 minus y1 over x2 minus x1. That will give you the gradient. Now, we need C because C is the y-intercept. So this is our C when the line is intersecting y-axis. So when you find the C, you can write the equation y is equal to mx plus c. You can also write this equation in this form: ax plus by plus c is equal to 0, where a, b, c are integers. So this is the two way we can write the straight line equations. So let's start the exercise question that will give us idea how to find the gradient and y-intercept. Exercise 5a, work out the gradients of the line joining these points. So we have a two coordinate. So this is our x1, this is our y1, this is our x2 and this is our y2. We know the gradient formula m is equal to y2 minus y1 over x2 minus x1. So, our y2 is 2 minus minus 4 over x2, which is 10 minus minus 2. So, that will give you 2 plus 4 over 10 plus 2. That means it's 6 over 12, which is half. So, the gradient for this we are telling as a half. Do the other question. Here p and p squared, q and q squared, two coordinates are there. So this is x1 y1, this is x2 y2. M is equal to same formula y2 minus y1 over x2 minus x1. Substitute the value q squared minus p squared over q minus p, right? Now we know q square minus p square is equal to q plus p, difference of 2 squared, and q minus p over q minus p. So q minus p will get cancelled. So we will end up with the q plus p. So the gradient for these 2 points is q plus p. Question number 2. This line cut the y-axis at 0c. Work out the value of c in each case. So this question we can do two ways. I will show you both ways. The first, we can make y subject. So that will give me c as an intercept, right? So what I can do is 4y is equal to 5x minus 2. So y is equal to 5 over 4x minus 2 over 4. So y is equal to 5 over 4x minus half. And I know c is my y-intercept. So that means I can write c value is minus half. Another way, because we know the coordinate, so we can substitute coordinate in this equation. So I can substitute x is equal to 0 and y is equal to c. So minus 5 into 0 plus 4 into c plus 2 equal to 0. So 4c is equal to minus 2. I moved this side. So c is equal to minus 2 over 4. C is equal to half. So as you can see, both way we are getting the same answer. So this question you can do two ways. It's up to you how you want to do it. What you feel easy. Move to question number 6. The line 5x minus 4y plus 20 is equal to 0 meet the y-axis at point A and x-axis at point B. Work out the coordinates of A and B. Now we know when any line intersect y-axis means x is equal to 0. So in this line equation, I am substituting x is equal to 0. So 5 times 0 minus 4y plus 20 equal to 0. So minus 4y is equal to minus 20. So y is equal to 5. So my coordinate of point A I can write as a 0, 5. Same, when this line meet the x-axis at point B, so that means my y coordinate is 0. So 5x minus 4y plus 20 is equal to 0. 5x plus 20 is equal to 0 because I am substituting here 0, so the whole term becomes 0. 5x is equal to minus 20, so x will become minus 4. So my coordinate of B is minus 4, 0. So this is the coordinate of A and B. We have to remember when the line intersect y-axis, x is 0. When the line intersecting x-axis, then y is equal to 0. And you can simplify, you will get the coordinate. Next question is question number 12. The straight line L1 with equation y is equal to 3x minus 7. Intersect the line L2 with the equation ax plus 4y minus 7 equal to 0 at the point P minus 3b. Now this point is the common point for both lines, or you can say this point is the solution for these two lines. So how to find the value of B and value of A? So first I will use equation y is equal to 3x minus 7. And I know P minus 3b is the solution of this line. So I will substitute B as a y and I will substitute minus 3 as a x. And I can simplify. So minus 9 minus 7. So my B I will getting is minus 16. So this is my value of B. To find the value of A, I can use this equation ax plus 4y minus 17 is equal to 0. Now this is the intersection point for this line as well. So I will substitute minus 3 for x and I will substitute B for the y minus 17 is equal to 0. But already we find out the value of y, so that I can substitute here. So minus 3a plus 4 into minus 16 minus 17 is equal to 0. So minus 3a minus 64 minus 17 equal to 0. So minus 3a is equal to, I am moving both this side, will give me 81. So divide by minus 3, divide by minus 3. So my A value I am getting is minus 27. So this is the value of A and this is the value of B. We have to use this common intersection point to solve both line equation. Let's move to past paper questions. As you can see in the figure, point P and Q have the coordinates minus 2, 13 and 4, minus 5. Straight line L1 passes through point P and Q. Find an equation for L and writing your answer in form of mx plus c. Y is equal to mx plus c. Now for that, first we have to find gradient. So for that I can rewrite this one as a x1 y1 and this is a x2 y2. That can help us to find the gradient. So m is equal to y2 minus y1 over x2 minus x1. So minus 5 minus 13 will give me minus 18 and minus minus plus 2 and 4 plus 2 will give me 6. So my gradient is equal to minus 3. Now, this question you can do two ways. Either you can use a line equation that we will learn in the next topic, which is y minus y1 is equal to m into x minus x1. And if you don't know this equation till now, then we can use another method. So what I can do is, I know my equation is y is equal to mx plus c. I have to find the value of c. Already I find m. I can use either of any coordinate. So I can use minus 2 and 30. So instead of y, I can substitute 30. My m is minus 3 and my x I can substitute is minus 2 plus c. So when we simplify, it will give me the value of c, which is a y-intercept. So 13 is equal to 6 plus c. So 13 minus 6 is equal to c. So my c value is equal to 7. Now rewrite the equation by using both value m and c. So my m is minus 3x and my y-intercept is plus 7. So this is my equation of line in form of y is equal to mx plus c. You can use this equation as well. That will also give you the same answer. Question 2. Figure 2 shows the sketch of the straight line L and curve C. Line L cut the y-axis as minus 12 and the x-axis at 4. Find equation of line in form of y is equal to mx plus c. Now to find the equation of line, we need two things, gradient and y-intercept. And to find the gradient, we need two coordinates. So here is the hint about the coordinate. The line cut y-axis as minus 12. When they cut y-axis, that means x coordinate is 0. So 0 minus 12 is one coordinate. And now another coordinate is 4, 0. Because they intersect the x-axis at 4. Now label x1, y1, x2, y2. So our gradient m is equal to y2 minus y1 and x2 minus x1. Minus and minus plus 12 over 4. So my gradient is 3. Now to find c, y-intercept, I can use y is equal to mx plus c. And here I can use any of this coordinate. So I can use y is equal to minus 12, m is 3 and my x is 0 plus c. So my c is equal to minus 12. Now rewrite the equation again. So y is equal to, my m is 3x and my c, y-intercept is 12. So this is the equation of a line. Next question. Line L1 has the equation 3x minus 4y plus 20 equal to 0. Line L2 cut the x-axis at point R80 and which is parallel to L1. We have to find the equation of line L2 in form of ax plus by plus c is equal to 0. So we have two informations. We have one point R, which is coordinate have 80, and we have this line equation. Now when two lines are parallel, they have a same gradient. That means if I will find the gradient for L1, the same gradient for L2 is there. Now to find the gradient for this line, I have to rearrange this equation into y is equal to mx plus c form. So 4y is equal to minus 3x, no plus 3x because I am moving 4y this side, plus 20. So y is equal to 3 over 4x plus 20 over 4. So y is equal to 3 over 4x plus 5. So the gradient is 3 over 4 for L1. So for gradient of L2 is also 3 over 4 because both lines are parallel, so they have the same gradient. Now to find the equation, I have this coordinate, I have a gradient. So I am using this formula y minus y1 is equal to m into x minus x1. You can use y is equal to mx plus c form and you can find value of c. But this is easy here, so I am using this one. So y minus 0 is equal to, my m is 3 over 4 and x minus 8. So y is equal to 3 over 4 x minus 8. I am moving 4 this side, so 4y is equal to 3x minus 24. So I am rearranging in this form. So 3x minus 4y minus 24 is equal to 0. So this is equation of line for the line L2. Important takeaway for this lesson. We can write equation of line two way. The first one we can write as a y is equal to mx plus c. In that m is a gradient and c is y-intercept. Right? Another way we can write is ax plus by plus c equal to 0. So you can rearrange this formula in this way. To find a gradient, we have a formula m is equal to y2 minus y1 over x2 minus x1. Collinear point means the points are on the same line. So that means we have to know the gradient of these two lines are same. So suppose we have point A, B, C. So first you have to find the gradient for AB and then gradient for AC. And then we have to write they have a same gradient and point A is common, so their points are collinear. Always use a fraction rather than decimal for the gradients. That can help you for the simplification. Thank you for watching this video. If you find this video helpful, please give it thumbs up. Do subscribe for more math content and let me know in the comments if you have any questions or topics that you would like to see next.